Welcome to our exciting journey through balancing chemical equations. Today we're going to explore the fascinating world of chemical reactions and how to balance them. To start, can you tell me what you already know about chemical equations?
I know we have our reactants and products.
That's a great start. In a chemical equation, reactants are the substances that undergo a change, while products are the new substances formed as a result of that change. Now, can you give me an example of a simple chemical reaction with reactants and products?
H2O,
Great, you've mentioned water, H2O, which is a product of certain chemical reactions. However, we need both reactants and products to complete the equation. For example, in the reaction of hydrogen gas, H2, and oxygen gas, O2, we produce water, H2O. The equation looks like this: 2H2 plus O2, 2H2O. Can you identify the reactants in this equation? Exactly. The reactants are hydrogen gas, H2, and oxygen gas, O2. Now let's talk about balancing this equation. The law of conservation of mass states that matter cannot be created or destroyed in a chemical reaction, so we must have the same number of each type of atom on both sides of the equation. Can you count how many hydrogen and oxygen atoms are on each side of the equation? Almost there. Let's clarify that a bit. In the balanced equation 2H2 plus O2, 2H2O, minus on the reactant side we have minus 4 hydrogen atoms from 2H2, 2 oxygen atoms from O2. On the product side, we have 4 hydrogen atoms from 2H2O, 2 oxygen atoms from 2H2O. So both sides have 4 hydrogen atoms and 2 oxygen. Awesome. Let's balance the combustion of methane, CH4, as an example. The unbalanced equation is CH4 plus O2, CO2 plus H2O. Can you start by counting the number of carbon, hydrogen, and oxygen atoms on both sides of this unbalanced equation? I can see you've been working on the whiteboard. Your equation CH tort plus 2O2, CO2 plus 2H2O looks great, and it's balanced. You've got 1 carbon atom on both sides, 4 hydrogen atoms on both sides, 4 oxygen atoms on both sides, 2 from O2 and 2 from 2H2O. Fantastic job. For your next step, try practicing with another equation. How about balancing the combustion of propane, C3H chat? Give it a shot. Great question. The unbalanced equation for the combustion of propane, C3H, is C3H jet plus O2 CO2 plus H2O. Your task is to balance this equation. Start by counting the number of carbon, hydrogen, and oxygen atoms on both sides. What do you find? I can see you've been working hard on the whiteboard. Your balanced equation for the combustion of propane is correct. C3H plus 5O2, 3CO2 plus 4H2O. You've got minus 3 carbon atoms on both sides, 8 hydrogen atoms on both sides, 10 oxygen atoms on both sides. 5O2 gives you 10 oxygen atoms, and 3 CO2 plus 4 H2O gives you 10 as well. Fantastic job balancing that equation. For your next step, try to practice. My apologies for any confusion. The balanced equation we discussed is for the combustion of propane, C3H, and looks like this. C3H dot plus 5O2, 3CO2 plus 4H2O. In this reaction, propane reacts with oxygen to produce carbon dioxide and water. Would you like to try balancing another chemical equation, or would you like to explore a different type of reaction? Great, let's try balancing the reaction for the synthesis of ammonia NH3 from nitrogen gas N2 and hydrogen gas H2. The unbalanced equation is N2 plus H2 NH3. Can you start by counting the number of nitrogen and hydrogen atoms on both sides of this unbalanced equation? What do you find?